This conference will now be recorded.
Hello students, we have been discussing wave optics. So far we have completed up to interference and Young's double slit experiment. So today what we are going to do is to discuss previous year's questions from NEET and JEE papers on interference and Young's double slit experiment. So mostly I think today mostly we'll be having questions from NEET paper, few maybe from JEE paper, JEE main. I'll actually pick up more problems in the subsequent classes. So let us discuss whatever we have today. So the first question is from JEE main 2023 or from the last year's JEE main papers. If the ratio of amplitudes is 2:1 in Young's double slit experiment, then find the ratio of maximum intensity to the minimum intensity. So for this, you have to remember how the maximum intensity is related to the amplitudes and minimum intensity is related to amplitudes. Okay, if I give you this, look, if you remember, I had derived this expression I is equal to square root of I1 plus, obviously this is square, I2 square. I'll just write, instead of writing square root, I'll write I1 plus I2 I1 plus I2 2 into root over I1 I2 cos of phi. This is the phase difference. Okay, so in case of maximum, what we had seen, so see, if I write this in terms of amplitude, how I will write? So ratio of amplitude is given, so I have to write in terms of magnitude. So let us see, if we write this side in terms of amplitude, how it look. See, this will be A1 square, this will be here A2 square plus square root of 2A1 A2 and cos phi. So in terms of, so this is intensity, expression for intensity in terms of amplitudes. Okay, amplitudes of two interfering waves. Now look, amplitudes ratio is given, but I have to find out what is the maximum intensity and minimum intensity. So we know the maximum will happen when it is, the cos phi is 1. So we'll write in that case I see, this is actually A1 square A2 square. Ultimately this square will not be there. I'm sorry, the square root will not be there. So this will be A1 A2. So Imax will be, see, cos phi is equal to 1. So in that case, Imax will be A1 plus A2 whole square. Okay. Similarly, this will be minimum when cos phi is equal to -1. Okay. So in this case, look, this is cos phi is 1. And in case of minimum intensity, we know A1, see, this cos phi will be -1. Okay, so A1 minus A2 whole square. So here it is cos phi is equal to -1. Okay, so we have got the expression for the maximum intensity in terms of amplitudes and minimum intensity in terms of amplitude. So let us write now here Imax by Imean. Imax by Imean is, see, a1 plus a2. See, if I just take this ratio, see, this is 2a. Let us take this as 2a plus a whole square, and divided by 2a minus a whole square. So this gives rise to 9 by 1, or 9 is to 1. So option C will be the correct answer for this question. Okay, so students, you have to remember this master formula for intensity. Okay, both in terms of amplitude and the intensity. All right, so this is the answer. Now this is mostly from NEET. The energy in the phenomenon of interference is conserved, get redistributed, is equal at every point. So energy is not equal at every point, because we have seen that bright and dark. At every bright it is equal, at every dark it is 0. That is what we have seen, isn't it? So intensity is maximum here, here minimum, that means 0 here. Energy, okay. So energy is actually not same. That is what I can say. Is destroyed in regions of dark fringes. Destroyed, actually energy cannot be destroyed according to law of conservation of energy. So this is also not true. Energy is created, okay, is created at the point of bright fringes. This is also not possible. Energy creation and destruction both are not possible according to law of conservation of energy. So this is the thing we have already discussed in the previous class. Okay, so energy conservation law will be satisfied by this interference phenomenon, because so the energy from the dark region, okay, dark region will be actually transferred to the bright region. Okay, that is what it is. So the energy gets transferred or redistributed, you can say. Okay, all right. The second question is the resultant amplitude. Like third question is the resultant amplitude of interference with two coherent sources depends upon. See, resultant amplitude. Resultant amplitude is what? I hope this also you remember. I'm just writing. Just see if this is resultant intensity. I hope you remember. We had written a1 square plus a2 square plus 2a1 a2 cos of phi. Okay, so this is the resultant amplitude, and if we multiply k, I can write intensity in terms of intensity as well. So you can see that the resultant amplitude depends on both the amplitudes. See, amplitude of the first wave, amplitude of the second wave, and also this thing is important, that is phase difference. So phi. So here we'll see it depends only on the amplitude, it depends only on the phase difference, both on both the above. This is correct, actually C is correct. Both amplitude. So resultant amplitude in interference depends on both amplitude and phase difference between the waves. Okay, let us go to the next problem. This is not problem, but anyway, these are analytical questions. Which of the following nature of the light is supported by interference? So I'll repeat the question. Which of the following nature of light waves is supported by the phenomenon of interference? Whether it is the longitudinal wave or transverse wave, or both longitudinal and transverse. So it depends on, see, interference actually, it depends on, see, we know that interference phenomenon, even in seen in case of sound also, right? Which is actually longitudinal in characters, okay? Longitudinal in nature, sound waves. And we are seeing in case of light also, so that is, see, light, this is transverse, okay, transverse nature. So here the question is, which of the following nature of the light waves is supported? The waves are longitudinal waves generating from a coherent source. When we place a screen in front of these waves, we get a similar interference pattern. Therefore, interference occurs in both transverse and longitudinal waves. So we can actually go with this option because we know the interference occurs in both the cases. Wave nature of, actually, what to say, it happens for both actually. So none of the above, we cannot say none of the above. So we can actually, when we will learn about polarization, there we will see polarization actually. Polarization cannot occur in case of longitudinal wave. It requires, actually polarization indicates or refers to the transverse wave of light, transverse waves, transverse nature or transverse, yeah, transverse nature we can say. In case of polarization, we can say the transverse nature of the light is actually supported. But in this case, since both longitudinal and transverse wave, both cases we see the interference pattern or interference, so it occurs in both cases. Hence we can actually choose the third option. Okay. Now, fifth question. For distinct interference pattern to be observed, necessary condition is that the ratio of intensity of light emission by both sources should be. For distinct interference pattern to be observed, necessary condition is the ratio of intensity of light emission by both the sources should be 2:1, 1:2, 1:1, 1:4, etc. So you have to find out this answer. See, for this actually, see, what is the necessary conditions? We need to know what is that necessary conditions. We had indirectly discussed it, but we did not say this is the necessary condition for observing distinct interference pattern. Let me tell you. See, the amplitude expression for the amplitude, you know, I hope you know this because we have already discussed. I'm not going to derive the same thing again here. So you know this is 2a1 a2 cos of phi. Okay. Now look, if a1 is equal to a2, then so this a square will be a square plus 2a square cos of phi, right? That means you know this is 2a square. If I take common, so it will be cos of phi. Okay, 2a square cos of phi. And if we use the trigonometric identity, you know, 1 plus cos of 2 theta is equal to cos of 2 theta is equal to 2 cos square theta by 2. So this is the one. So if we just write in terms of that, you know, you will get 4a square cos square pi by 2. Okay, this is the thing, this is the expression. Okay, I'll just write correctly or with highlight here that so this is actually the necessary conditions. Okay, this is necessary condition. This is necessary condition. This is the necessary condition for observing distinct interference pattern. Distinct interference pattern. So look here, if this is the necessary condition, then we have taken a1, a2 is equal, they are equal to a we have taken. That means you know they have similar they have same amplitude. If they have the same amplitude, then what will be the intensity ratio? The intensity will be a square by a square, which is 1:1. 1:1. I'm sorry. This, that's why amplitude of both is same. Okay. This was another question. Good question. Let us go to the next page. Okay. So this question says the phenomenon of interference is not observed by two sodium lamps of same power. It is because both waves have not constant phase difference, zero phase difference, different intensity, different frequencies. Okay. See, since both are actually same identical lamp and both are actually given the same power, so frequency is not going to be different. Okay, they will be almost similar. Intensity also will not be similar. Frequency will not be this different because same what to say, the sodium lamps are actually, see, there are energy levels, right? So the light we get from the same jump of the electrons. Okay, so that's why frequency cannot be different, and also intensity cannot be different because they have been given same power, same flux of electron, light or photon will be generated. Zero phase difference, this we don't know, but anyway, for interference pattern, zero phase difference is not mandatory. The thing is that the interfering wave should have constant phase relationship, but here see, the first option is not constant phase difference, not constant phase difference, so this will be actually answer. Okay, so with sodium lamp, with two sodium lamps, we cannot have interference pattern because their phase relationship is not constant. Okay, now we'll go to the next problem. So this problem says two beams of light having intensities I1 and 4I2 interfering to produce fringe pattern on screen. The phase difference between beams is this and this. So this at A at a point A and 2 pi at a point B. Then the difference between the resultant intensity at B and A. See what it is saying, that two interferent beam which has intensity I1 is equal to I and I2 is equal to 4I. Now when they interfere at certain point, suppose this is point A, their cause, see, this phase difference is becoming pi. Okay, all right, so this is for A, point A, and when they meet at point B, their phase difference is 2 pi. Okay, phase difference is 2 pi. Now we have to actually find out the intensity ratio at A and B point. All right, so how to do that? Similar thing. See, I know I is equal to square root of pi 1 plus square root of pi 2 to so this cos phi here is very important. You can see that cos phi. Okay, this cos phi is important. Now let us just put, suppose IA, I want to find out intensity at A. So this I1 is I. I'm again and again doing the same mistake. This will be I, not square root. Okay, so yeah, this also I'll remove. So I1 is I, I2 is 4I plus 2 into I1 is I again, and this is 4I. Okay, and along with that cos phi means how much here? Pi by 2. If the cos pi by 2 is 0, so this term will be actually not there in like at the place of A. So I get here how much at A intensity we are getting as 5I at so right hand term will be 0, so this part will be 0 because cos I am just taking, see, pi by 2 is the phase difference here. Okay, so it will be 5I. Now so I'll just erase this part. IA we have got 5I. Now IB means, see here also I1 plus I2 plus 2 into here cos of 2 pi. Cos of 2 pi means 1 only. So as I said, I1 is, see here it is 1. See I only. I2 is 4. I I1 I2 is 4 again, 4 I square. That means it will be 2I. This is 5I plus 4I into this. Okay, I'm sorry, this is into 1. Okay, this is into 1. So you get ultimately 9I. So what is the ratio? Sorry, difference. So a difference is IB minus IA. So IB we have got 9I, and IA we have got 5A. So what we have got? 4I. Okay, so intensity difference will be 5I. All right, so this option C is correct here. Now what I'll do, I have few questions which I have not written in this. I'll just directly write over here. Look, uh, this question we had already discussed somewhat in the previous class. So this, suppose this is question number 8. The question says Young's experiment is performed in air. Performed in air, and then performed in water. The fringe width number A will remain same. Option B will decrease, will increase. And option D is will be infinite. Infinite. So guys, we had already discussed yesterday, if you remember. In this case, the new fringe width will be the old fringe width or fringe width in air divided by mu of the material. So this is material inside any material, any medium. So the refractive index of the medium will be refractive in the fringe width in air divided by mu. So you know this, so in case of water it is actually greater than 1.33, somewhat like that. So since it is greater than 1, obviously fringe width will decrease. It will never be remain same. Okay, it will decrease. Okay, so now related to this question itself, like similar with this concept itself, there is a question given in some NEET paper. Let us see that. Question number 9. In Young's experiment, light of wavelength 6,000 angstrom is used to produce fringes of width 0.8 millimeter. Okay, at a distance. Okay, D is given at a distance of 2.5 meter. Sorry, 2.5 meter. If the whole experiment is deep, EXPT is deep in a liquid of refractive index. Okay, I'll write Ri. Refractive index, let us say mu is equal to 1.6. Then the fringe width will be number 1, 0.5 mm, number 2, 0.6 mm, and this is 0.4 mm, and option D is 0.2 mm. Okay, so as we know, so fringe width already has been given beta. Okay, so no need to use this and wavelength etc. D lambda by D, we would have done D lambda by D. The fringe width is also not given. So what to do? So beta in liquid will be beta in air divided by mu. Okay, so beta is this millimeter divided by 1 point. Mu is 1.6. Okay, so what you can do, this will be, say if I just strike this 2 out, so it will be 0.5 mm. Okay, So this will be answer. I think the first, yeah, first option is the correct answer here. Okay, so we can take some more problem. Let us take. I think the questions are similar kind of questions have been asked. We'll take next day. We'll take, these are mostly from NEET papers, previous year's NEET paper, or JEE main. Some of them are. So in Young's double slit, experiment, if width of the slits are if the width slits are in the ratio in the ratio 4:9, the ratio of intensity, the question is the ratio of the intensity of the intensity at the ratio of the intensity of maxima, the ratio of the intensity of maxima to the intensity at minima. This is maxima and to the intensity at minima. So we have to find out the ratio, right? So I think there are options. I'll just pick up the options here. First option says it is option B is option C 25:1 and D this is 9:4. Okay, so we have to check what is the answer for this, right? We have to actually understand to answer this. We need to understand. We need to understand what is the okay, ratio of the intensity, width of the slits. Okay, slits of the, like how intensity is related to the slits. Okay, intensity means more light, isn't it? More amplitude. If the amplitudes are more, then intensity also will be more, right? I think there is a direct proportionality relation with this. Okay. So let me read out the question once again. In Young's double slit experiment, if the width of the slits are in the ratio of 4:1, then okay, let me just do it here. See, width means the ratio of width means ratio of, they're directly related actually. I1 by I2. Now we have to see that I1 intensity ratio is given, right? Intensity ratio of intensity. Okay, sorry. If the width of the slits are Young's modular double slit experiment, if the ratio of the slits, if the width of the slits are in the ratio, so these are actually ratio of width of the slits. Okay, so this will be I1 by this, right? In this ratio 4:9, if we just multiply, so the question is we have to find out the intensity ratio of the maximum and minimum. So let us just multiply this. So Imax will be how much? Imax will be actually I1 plus I2 plus 2 into root over 4k into 9k and cos of, so this is maximum intensity means, okay, this term will not be there. Cos phi is equal to 1. Okay. So what about minimum? Minimum will be this. This will be like this, and minimum intensity will be okay. So now we have to get the ratio, right? Look, this is 13, right? Here 13 plus 2 into 2, 3, 6, 2 into 6. Here it is 13 minus 2 into 6. So this is actually 25 and this is equal to 1. So the option 25:1 will be correct answer. All right. So this is actually the answer. Okay. So answer is C. 25:1. All right. We'll stop it here for today with this. Next day, specifically, we will take questions from the JEE main papers and advanced papers. That is tomorrow. So and then we'll proceed further for the rest of the chapters. Okay, diffraction, etc. we'll discuss. Okay, I think I just leave with, okay, tomorrow we'll discuss again. All right, so tomorrow also we'll continue this PYQ discussions on interference Young's double slit experiment. Mostly we'll pick up questions from JEE papers. Okay. All right, so thank you for your patience. Bye for today.